So, it's been a while since we've not been separated by a glass screen. My name's Mike. I'm CEO of Merkle, which is a Norwegian word. It means Merkle tree, which is a data structure in Git. People often say that, I'm Mike. Mike is Merkle. So I'm very happy about that. Anyway, so today we're going with the Norwegian. Don't want to sell from stage, but that's it. So, every now and again you read a book and it kind of changes the way you think about things. And I read this book quite some years ago, actually. And I haven't stopped thinking about it since. And I've been thinking there's something here about what we do in our jobs as well. It's written by a guy called David Deutsch. He's a quantum physicist based in Oxford. But this is more of a book about, you could say, the philosophy of science and progress, actually. And what he says is, progress that is both rapid enough to be noticed and stable enough to continue over many generations has only been achieved once in the history of our species. And his thesis is that since the beginning of the Enlightenment, we've kind of started down this path of infinite knowledge creation. And it comes around by what he calls good explanations. He says all progress, both theoretical and practical, has resulted from a single human activity, the quest for what I call good explanations. Anyway, you'll see that it's a well-thumbed book for me because he's smarter than I am. So it took a while for me to figure it out. But hopefully I'll make it understandable to you. So this idea that what knowledge is about explanations. This is what science is. This is about what the Enlightenment was. And he says that explanations have got reach, or the best ones have reach at least. And the way this engine of knowledge creation works is around conjecture and theory and creativity. But on the other side, there's also experiment and criticism and fallibilism, the idea that your ideas can be proven wrong. It's a really important part of the mechanism. And because things can be wrong, you also need error correction. This is where we balance these things. We come up with ideas, and then we challenge them, we criticize them, and come up with better ideas over time. And what I came to think about is, actually, this is kind of what the DevOps infinity loop is about as well. This is around making new features, making new ideas, changing the way we think about our products and our systems. Trying them out, testing them against the real world, finding out how they break, finding out new ways to improve. And this whole engine of what we call DevOps is really about coming up with better and better explanations for how we make software. Now, in the book, David Deutsch, he has many, many meanings of infinity, or what he means is the beginning of infinity. Because what he thinks is we're just at the very start, and you're always at the very start of infinity by definition. So he says that the Enlightenment is a meaning of the beginning of infinity. There's a knowledge friendliness of the physical world. People are universal constructors. Error correction and computation. These are all different ways to mean the beginning of infinity. And I wanted to try and play with this idea a bit and think about the ways that we're just at the beginning of infinity in DevOps. So what does it mean, this idea of DevOps infinity? In 2013, how many people have read the Phoenix Project? Okay, quite a lot. It was a book almost 10 years old now, and it's basically a novel, in the business kind of world around how to improve an IT project. It was kind of one of the first really big DevOps books, actually. And this is data from within the book, and he was talking about, this is from one of the appendices, actually. So back then in 2013, the typical enterprise deployed once every 9 months. That was not long ago, actually. 8 years ago, the typical enterprise was doing it like this. How many people here deploy more than once a week? Right, so as most of you are kind of catching up to where Twitter was 8 years ago. And I'm sure Twitter's deploying more than 3 times a day now, right? And for sure, Amazon's deploying more than 23,000 times a day. So we're just kind of beginning on this this curve, and it's just going to go up. And we see this in the data as well. This is from the 2021 State of DevOps report. And we see that what's happening is that the low performers are getting fewer, and the elite performers are getting more and more. So 26% of people or companies that respond to the State of DevOps survey are in the elite category of DevOps performance, which is quite impressive, really. And the elite category only started to exist a few years ago. So I don't know what the next one will be, ultimate or something like this. Does anyone recognize this? Come on. Maybe there's not enough pixels on this screen. So this is the current list of AWS services. These are the products that AWS is serving to its customers right now. And this is how it's growing over time. And there's not going to be fewer next year, right? There's going to be more. This is not like Apple, where there's only ever going to be 8 Apple products in the world at any given time. You know that there's going to be 500 by the end of this decade, more probably. It's just going more and more. And this is all technology we can leverage as DevOps engineers. Anyone recognize this? Yeah? Yeah, it's the CNCF landscape. That's the very first edition. This is it today. There's a trend here, right? I mean, this is an awful lot of open source that we've built and created, and we can leverage as a technologist. And again, this is not something that's going to stop. We're going to have more and more of this kind of technology. And we've got the Agile Manifesto 20 years ago, around about now. 4 sentences, really, about ideas for how to make software. And again, it just expands to infinity. Which brings me to my next subject, which is error correction. Sometimes things don't go exactly according in the right direction, right? And what David Deutsch says is, without error correction, all information processing and all knowledge creation is necessarily bounded. There's a limit to what you can learn or what knowledge you can create without error correction. Error correction is the beginning of infinity. And you know, there's lots of ways to challenge the orthodoxy. Like this is so I became a scaled Agile DevOps Maturity Fellow last week. I got the certification. I recommend you all do it. Enterprise transformation without the risk of culture change. It's a good idea, huh? You can batch up all this kind of busy, small little work into big batches that you can manage properly into release convoys. So, I mean, like, this is a bit tongue-in-cheek, but you get the idea. Through criticism, through challenging ideas, we also get better ideas about how to work. And what David Deutsch says is that there's a difference between good explanations and bad explanations. And good explanations are hard to vary. You can't change the explanation or change the system that it's talking about and still get the same result. It's very, very specific. They're testable, they're fallible, you can verify them in some way. They have reach beyond their initial explanation. So if it explains one thing, it can go on to explain further things. And they're fallible. So he gives many examples of what a good explanation is. For example, the jump to alphabets was a better explanation for writing than pictographs, because then we kind of have an infinite way to define things. Also, the jump from Roman numerals to digits. These are more universal. These are systems that have more reach. They're more expressive. And he goes on to say that basically his thesis is that everything is achievable given the right knowledge. The only thing that stops us from being able to solve any problem is knowledge. And again, there's a continuous process going on here. He says problems are inevitable. Wherever we are in history, there's always going to be problems. But he also says that problems are soluble, which is just a fancy way of saying that you can solve things. And what's interesting about this is that they kind of play off each other. So you solve something, and that produces new problems. So we kind of go through this loop. This is the engine that's driving the knowledge creation. We're always going to have new problems, and we're always going to find ways to solve them. And that knowledge is going to be the key to that. So how does that map into the DevOps world? So as an industry, we've kind of gone through quite a shift over the last, say, 30 years. And in the beginning, we had servers, right? We had systems that we managed. And then we create a profession around that to be able to handle that, to be able to think logically and professionally about this, learn about how to manage these systems, how we manage more than one server and so on. But that brings new problems. We understand that as we get more and more servers, managing them with systems administrators was hard work. But we solve that again. We build better tools. We script. We have bootstrap systems. We create virtual machines and so on. And we kind of gone through this loop many, many times in the last 20 years. We started with system configuration, and then we realized that, okay, we start to see drift between what we think our systems are and what they actually are. So we build configuration management tools like Chef and Puppet and Ansible and Salt. And then we realized, okay, but now we need to figure out a way to provision systems in a scalable, predictable way. So we get Terraform and CloudFormation and so on. And then we realized that it's actually a pain to have this big separation between the definition of our systems, the code, and the dependencies that they live with and need. So we come up with tools like Docker. And then, we'd like a better way to run containers, so we come up with Kubernetes. And then we want actually to stop thinking about servers in the end. We just want if a web request comes in for an API, we want that code to be executed. And that's all. And if there's 1 million requests, we want it to scale up. And if there's 0 requests, we don't want to pay a penny. So we get serverless. So with each loop, we're kind of building upon higher and more powerful abstractions. And this is all kind of part of that jump to universality that David Deutsch talks about. I mean, there's areas in DevOps where I think we've really kind of solved things in a universal way. Like, I believe that, as an example, like areas where we haven't got universal solutions are CI systems. Every CI system has its own way of scripting it, its own peculiarities. There's not a universal way for defining a pipeline. And I think that's an area where we probably could do something in DevOps. And it's actually quite a low-hanging fruit. But there's other areas where we kind of have got a universal things, like containers are really like a universal way to define a runtime for things. And then we kind of move into, well, how do we build this engine that makes these improvements in DevOps? How do we have these infinite cultures? And for me, like, culture is kind of an interesting thing. We talk a lot about it in DevOps, but for me, it's kind of, it's like the fallback system of any organization. Mitch Hedberg, he's a comedian in America, and he says, I like the escalator, man, because it can't break. It just becomes stairs. And I think that's how I think about culture as well. When things are not working, when you have problems, when problems arise, it's all about your culture. That's what you kind of fall back on. The escalator becomes stairs. Your organization becomes its culture. And what David Deutsch says is static societies are inherently unstable in the face of new problems. So the more rigid, the more defined your organization is, the harder it is to solve new and novel problems. It's harder to solve this. And there was a great piece of research done by Repenning and Sturman, again, 20 years ago. They were looking into how organizations were thinking about like lean product, lean manufacturing around process improvement, about how companies do and do not achieve like continuous improvement in their organizations. And they had a great title for this. It's Nobody Ever Gets Credit for Fixing Problems That Never Happened. And that's kind of the problem with continuous improvement. If you're doing it, you don't see it, right? The benefits are just kind of taken for granted. But if you have problems, solving them is, that's immediate credit. So they kind of looked into this, and they found that there was a pretty model, and they kind of weighed up the continuous improvement between working harder or working smarter. Everyone knows you should work smarter, but many organizations really struggle to do so. What they found is that there was this work harder loop, what they call B1, which is the pressure to do more work increases the time spent working, which delivers performance in the short term, but decreases performance in the long term. So it's kind of you get very short-term results from doing overtime, hacking effects. All of this is very short-term, near problems. But in order to solve continuous improvement, you need to have pressure to improve capability. That needs to be pushed into the system so that people actually spend time on improvement. But there's a delay, and that's the important part. That delay is the reason why most organizations struggle to do it, because you don't get the immediate gratification of the results. It takes time to see results from continuous improvement. And what's really interesting is that this whole loop, what it ends up doing is feeding an asset called capability, which is another way of saying knowledge in an organization. Capability is just knowledge applied. It's the verb for the noun as far as I'm concerned. So this idea of the real asset in your organization is capability. The only way to build that is by injecting pressure to improve. Now, how do we do that, for example, in the small, where we're sitting as technologists? In Merkley, we do a lot of ensemble or mob programming. We almost never work alone. If it's sales, if it's marketing, if it's coding, if it's the DevOps, whatever it is, we very rarely work alone. And the reason is that we all have good days, and we all have bad days. And we all have strong skills, and we all have weak skills. So, whatever you get out of an individual goes up and down, considering the context or the environment for the person. But as you kind of work together more and more, what you end up getting is the best of everyone, because none of us is as good as all of us. There's just no way for that to be true. So if you think about quality, if you think about technology, and you think about building knowledge, you really want to get the best of the whole team into the product. So the best way to do that is never work alone. Just out of interest, how many people regularly do pair or mob programming? Okay. So, in the end, what you want is the best of the whole team to make it into the code, into the product, into the procedures, into everything you do. There's a great newsletter about engineering management called Pragmatic Engineer. And the guy that, Gregory, the guy that writes the newsletter, he does a lot of research into how different organizations actually do their technology. He's an ex-Uber manager. And this is part of looking at how big tech, how the most successful tech companies actually manage tech projects. And I find it quite interesting because it's quite different from what you see in the typical organization. A big important one, central pillar for me, is that there is no central methodology. Nobody's forced to follow SAFe or Scrum or any other process. There is no one process to rule them all. Every team is given the power to work on their own things, which seems messy. It seems unmanaged, but actually going back again to capability, coming back to new problems arising, this is the only way to really build strong tech teams. And then the other part of it is who typically leads tech projects. And in big tech companies, it's tech leads or engineers. There's no managers that are running them. If there's connective tissue needed or if there's product management needed, they come in from the side, coordination. But there's no hierarchy that delivers technology in these organizations, which I think is quite interesting. There's quite a common phrase from organizations around the world that says our people are our greatest asset. And I think this is wrong. I've been thinking about this for a long time. I think this is really wrong-headed as well, because first off, people are not assets. And second off, the company doesn't own them, so they shouldn't be on your balance sheet. It doesn't make sense. And I think a better way to think about people is that the connections between people, the relationships between people, and the work they do together, the collaboration, is what produces your IP, is what builds your culture. That's really what your asset is. And you should start to think about, instead of thinking about the nodes on the graph, you should think about the arcs. Again, it's nouns versus verbs. This bit is much more interesting than the individuals. So I have to say, David Deutsch is an optimist. He really believes that we're on the path of infinite progress. And I mean, I think it's brave to have that attitude, but I hope he's right. So he's got this principle of optimism. All evils are caused by insufficient knowledge. It's quite a powerful message, I think. But the thing is, what do we do with that? How do we take that optimism into our work? And Teddy Roosevelt says you should do what you can with what you have where you are. So, I mean, you don't have to solve your entire organization or your entire industry, but like small steps where you are can add up to a big difference. Andy Grove has got this great book, Only the Paranoid Will Survive. He talks about his time managing Intel from being from being a memory business to being a microprocessor business, changing that whole organization. And he says that, you know, whatever can be done will be done. I think that's quite an interesting message too. So, must progress come to an end, either in catastrophe, or do we complete the game? Do we beat the end-level baddie and we live in utopia forever? He says, no, it's unbounded, and this is how we should think about the world. So that was all I wanted to say. Hope it was interesting. Thanks a lot.
Hello? Okay. Thanks, Mike. Just before I introduce the next talk, I mean, a lot of what Michael said I think was quite thought-provoking, and hold on to your thoughts because we'll have an open space session where you'll get the opportunity to ask those questions and discuss some of the principles he's talked about. So I just wanted to mention that. Our next talk is Alexander, who is just getting himself ready. And his talk will be measuring software delivery and operational performance to improve commercial outcomes. Feel free to have a look on Sessionize as well so you can see the list of speakers and what's coming next. And the next sponsor that we have on is Merkley. Mike.
Hi, everyone. Again. But maybe I should be on brand for this one. I've got a Merkley t-shirt under here. Yeah, what's there to say? So Merkley is a DevOps tool for teams, technology teams in the enterprise, especially regulated industries. So we help automate change management and compliance controls in your pipelines, building audit trails, provable audit trails, and basically getting rid of manual paperwork, cab meetings, and all this other nonsense that doesn't make sense. So if you prefer pipelines to Jira tickets, we might have an interesting conversation. Thanks.